Okay, and we're live with another episode of The Focal Thought. And my guest today is Anil Vaz. How are you, Anil?
Hey, good, Gordon. Very well.
Thank you
And
so
yourself?
much for doing this podcast. And the first thing I want to start with is, we grew up in elementary school together. And, ever since back in the day, you were sort of like the MacGyver of everyone. I remember, bringing you sort of ideas. We used to take these old motors out of cars and I'd ask you, what fun stuff,
Okay.
can I do with them? And even back then, you were sort of drawing me basic schematics, attaching the wires to the motors, putting them on a battery, and then, devising sort of like a paper propeller, attaching it to the motor, and just getting these things to buzz. And I would
Oh
come
yeah.
up with, different fun projects. And you would always, have inventive ways of, being able to create these things. And this is at a young age, like maybe 11, 12. So how did you sort of get to sort of having a very scientific and inventive mind so young?
I don't know. I think it's what drew me to machines. I think machines are magical. I think no matter what you do, it's that innovation. It's that little bit of science. I think the science. I can't say fascinates or I think some people are so oblivious to the science that they don't realize that the magic behind it is actually science. It is something that draws you to it. Okay, your first question is, oh, that looks interesting. How does it work? And then from there you start moving on. So I guess that's what it was that started it off. And then you see these little flying machines. What makes them fly? Let's try it out. So, that's what I guess that's what started off in school, and then you just sort of start moving from there onwards.
Got
And
it. So it was sort of like a natural curiosity and then getting into, the basics of how things work, that sort of thinking.
curiosity is right, but at least curiosity doesn't kill the cat over here. But yeah, so yeah, it was more of that machines that kept me going. Innovations that you had in machines, and yeah, and I mean, it depends on how you look at it. Sometimes even science is a bit of art. The magic. You look at cars these days. Some of the cars look bloody beautiful. I mean, like I said, there's there's an absolute universe to this bit of science.
No, no, that's very true. There is, it's what comes first, the art of the science, are they intertwined? They're the basis for a lot of the inventions we have today, a lot of the thinking that's brought about, a lot of the machines, devices, that have implemented themselves into society. And what is it that drew you into airplanes specifically? Because you've got a fascination for them.
Oh, I've got a massive fascination. I think it's from the time I first got onto a 737, and it was this thing. I sort of got off the aircraft, and that whiz in the air, that was magical. I think that was the magical moment for me. I was about 4 years old, and I guess that's where it started. And you got ever since then. There's a point where I know it sounds like a joke at the time. I said, "Dad, I want to become an aircraft." And I I don't think anyone realized what I wanted to do. And from then onwards, it was like, how do they fly? What makes them fly? And you just sort of went on from there onwards. I mean, it was making little radio control aircraft. I mean, even till today, I still do that. But you get into to know a bit more engineering than you knew then. It makes it all the more real. And like I say, I mean, I get to work, and you get onto these aircraft. From aircraft you knew when the Wright brothers initially built them to what you see now. Oh, they've come a long way. I mean, it's over 100 years, but they've definitely come a long way. The aircraft that you see now, when I say magical, science is magical, that's what they are. It's this big, it's this big, it's this big aircraft, the big bird that just flies. I work on the 380s, on the Airbus A380s. I think that's the biggest I think I'm ever going to see. And it is the largest that I've seen so far, anyway. At least as far as passenger is concerned. It's I think it's the sheer size, the power that they had to them, and what actually makes you go. What makes it go? It's magical. It is definitely magical.
Got it, got it. And I like that because, I mean, most kids, they might dream or have an ambition of being a pilot, but you actually had an ambition of being the aircraft itself. So that's, I
Yeah,
like that.
that was the comic part of it. But it's the pilot thing. Yes, it does fascinate me. But it is what makes that it's like it's something like let's put it this way: if you were on the ground and you had to pull a car apart, it's the little bits and pieces that put it together that make it work. Yeah, the driver or the pilot is for me was secondary. I'm saying even their job's pretty fascinating, but for me it was the machines that actually made it go. It was good.
Got it, got it. And then, you were talking about, the Wright brothers, and, it's been almost, I'd say, yeah, definitely 100 years since, we've learned about, the Wright brothers doing their sustained aircraft flying.
Yeah.
And in terms of the evolution of the aircraft, with we popularly know the Wright brothers as, being the inventors of the aircrafts, but they actually built on, the people that came before them. So, Otto Lilienthal and,
Yeah.
George Calway. I know he also built, I would go even further back in history to, the primitive drawings of Leonardo da Vinci, sort of trying to get the cross section of the bird. And even before then, with Flight of Icarus, with, the
Yeah.
Greek mythology. So ever since, the dawn of civilization, man has sort of, and women, have sort of envisioned being able to take to the skies. And I'd say it's taken all of that time for the planning of the aircraft to evolve and materialize. And I'm the kind of person, I'm trying to figure out dark matter. And I would want to figure out dark matter before even thinking about, flying an aircraft or making an aircraft fly. But these people have just gone ahead and done it. So today, what is the state of the aircraft, and how far has it come since, you were saying that the Wright brothers invention 100 years ago?
Yeah. If you look at the aircraft, what they built then and what they have right now, let's put it this way: what you initially started with was a couple of sticks, a bit of webbing, an engine that kept them flying, as much as a kite would do. You look at it right now; it's a full metal aircraft. Well, when I say full metal, you've got your advanced technology that sort of put into composites, high-tech composites. What used to have a four-man cockpit early in when the great aircraft initially started coming out, which was your captain, first officer, the navigator, and the flight engineer. Well, you don't have all of that anymore. All you've got is a two-man cockpit. The aircraft has become completely automatic, where your engineer and navigator. Your navigator used to basically, I would say, at that time, what is your flight management system? Is your maps, charts, and everything that took you right through the globe. Once they managed to get that all computerized and all digitized, well, he disappeared. When the aircraft became a little bit more automatic, in the sense where if you had electrical power failures, a different takeover, redundancies in the aircraft, your flight engineer would take care of that. See that you got down with the minimum systems that you needed. Well, you don't need that anymore. What you have right now is the aircraft that automatically switches its systems to see that you've still got the systems to maintain the remaining part of the flight. Not just remaining part of the flight safely. With that, you see this complete evolution of what was flying a kite to basically flying a big jet right now, which are equate to what was 747 and what is the Airbus A380s right now. Just to give you an idea, on the 787s and the Airbus A380s, what runs the aircraft right now is a whole lot of software, computers that actually keep the logics and the systems up and running. Or just for example, on the Airbus A380, you got 1,700 software that keep the aircraft systems, air conditioning, landing gears, engine propulsion systems all running up to their optimum. It not just does that; it does the navigation. It does what used to do what the flight engineers used to do. it is like this complete powerhouse up in the sky, and supporting about 500 to about 800 passengers on board with
Wow.
a complete environmental system, entertainment system. Like I said, it's a little city in the sky. I mean, it's amazing from what it was to what it is right now.
And how much of the aircraft is human-based versus computer, software, hardware-based when operating an aircraft? What's the percentage there split?
Let's put it this way. Your aircraft these days is capable of taking off and landing completely without human interface. There was an old joke that we used to have it was more of crew in the cockpit. I'm sure they wouldn't be too happy with it. Whereas the next generation of cockpit crew would be a pilot and a dog. A pilot to ensure that everything's going smooth, and the dog to bite the pilot in case he does touch something. So if it's not broken, don't break it. It works absolutely fine. The aircraft these days, a lot of them used to ask me in the old days, oh, what if this happens? The amount of redundancy that's built into these aircraft is phenomenal. There's for something there'd be more of a chance for something to happen to you on the ground than it would be up in the air. I mean, you can actually see that in the everyday scenario. How many air crashes do you see per day compared with the number of aircraft that are actually flying? You'd hardly see one at a time. There aren't very many. And it's come a very long way from what used to be 75 minutes just running on 2 engines right across the Atlantic is now doing about 206 minutes, and can do that 206 minutes on a single engine. So
Wow.
it is amazing what you see, and the aircraft has evolved, technology's evolved. It's much more advanced than what it used to be.
Correct. And with the pilots, so I guess they're there sort of to be as a backup, right, in case the computer software fails.
That's true. They are there as a backup. I mean, there are some pilots that have done amazing. I mean, you've got Sully done safe then. Sometimes I think without guys like that, you would not have been able to get that aircraft the way it was. You would have had computers try to do the simulate thing. Sometimes it's the skill, it's the feel of the aircraft that you actually need to actually do what you need to do. You had Sully, you had the Air Transat aircraft where the pilot glided as it took off, and it glided into the Azores. He glided with no engines on, and like I said, the pilot is needed, and like I say, the pilot experience is definitely needed, because there's some things about human beings you just can't replace. Human
Correct.
beings yeah.
How would the pilot get their experience when a lot of the times it's the computer that's running the show? Is it through virtual training that they do offline, or how would that work?
Yes, it is. It is true. It's. I mean, pilots do go through an intensive simulator training. It's not just pilot training. It's even if you see pilot experience is looked at the number of hours they're flying. A lot of that. I mean, even though we say it's the number of hours, he's not doing anything, but there is a certain element of practical feel you get on the aircraft. Even if you say it is autopilot taken off or autopilot landed, in the practical world, sometimes you want that autopilot to land it because you want to know the system's working. A lot of the time, they need, for pilots to build experience, they need to see that they've got a number of takeoffs, a number of landings on their belt. So that experience will be there. So it's not negated from the equation, and they're definitely not put aside saying that, oh, it's completely automatic, you don't need to think about it. Oh, that's not the case. Even pilots are trained for the inevitable. They go through simulator sessions. I mean, I work in an airline, and things you can actually see the most stressful part of the pilot's job is them being reassessed for what they need to go through. So yes, they are trained. They are made familiar with what they aren't familiar with on an everyday basis. and that's how I would say that's how you keep the rest of us reassured that the pilot is completely competent.
That's the confidence factor, the amount of hours that they've logged. And we were speaking with the safety of aircraft, and I agree with you. They say generally aircrafts are 10 times more safe than the traditional transportation that we have: cars, motorbikes, buses, etc. But they do say also that the loss per passenger per fatality is more than the ground transportation. That's why I guess aircraft insurance is very high. So from what you might know, do you see any sort of common patterns why aircrafts crash?
Or if you look at the old days and now, well, if you talk about crashes, the crashes in the old days was, yes, because of, let's say, failure. I would say actual aircraft failure. Now, when you look at the current day scenarios, how many of these aircraft do you actually see crashing because of an aircraft failure? Because a lot of the failures are contributed to, I would say, error. It would either be a pilot error, maintenance error. It would be some sort of error that was human induced. It's not like back in the old days where you had structural failures or technical failures that actually caused aircraft to crash. These days, what you find is quite a lot of human intervention. When you talk about insurance, and when you're talking about insurance, not just covering the aircraft, you're talking about insurance of where it's going to crash, how it's going to crash, the freight it might be carrying, the people it might be carrying. There's a lot of factors where insurance is concerned. Sometimes the insurance flying over certain areas might not be the same as the insurance flying over other areas. There's a lot of factors in there as far as insurance is covered. Yeah.
Got it. Okay. And then what, when you say that, the crashes were because of maybe maintenance errors or human errors, what are some examples of that?
Okay, it's not a very nice one. It's like sometimes you want to tell the pilot, you would fly there if you knew what I knew. But anyway, let's put that aside. But okay, when we talk about maintenance errors, let's put it this way. A lot of this, as we do our daily routine, so we don't forget the engineers, technicians, and mechanics are human beings too. I'm not giving them a bit of grace over here. It's definitely not that. There is a chance of failure, but like, let's put it this way: he's put the bolt in, but he's not tightened it. Or yes, that does happen. If there's a question about, is that possible? Yes, it is possible. Now, so these would be some of the instances where you'd actually have a failure, incorrect construction, incorrect assembly. Now let's put it this way: the technician or the mechanic has had a bad day, or he's had an emergency, so he just leaves the job. And these are some of the factors that actually affect the technicians and mechanics down there. And in turn, unfortunately, it adds on to the aircraft. When we talk about maintenance errors, now there's a whole system that's built up around avoiding situations that like this. I am, even though I made it sound a little blunt and drastic at the moment, I do need some comfort to it also. So what I'd say is, you would have this entire scenario that's built up. Okay, you look at any of the technicians and mechanics that have disappeared off the maintenance area of the aircraft, and you trace back standard practices. You trace back a couple of steps that he's been working on to ensure that whatever he's been doing has been overseen and rectified, and then you put it back into place. For critical control surfaces or mechanisms on the aircraft, what the FAA and as well as the European safety agencies have had are what they call as RII, or independent inspections, where critical areas are built up, constructed, and everything. And then you have a second person doing a completely independent check on it, so that you don't have the same mindset. You've got completely independent mindset, a fresh mind that has a look at possible errors that may have taken place during the assembly or construction of that or repair of that part of the structure. These are done right for the engines, the airframe, landing gears, whatever is deemed as critical on the aircraft. Yeah.
Got it. So just like a pilot might have a checklist that they go through before taking off, the maintenance crew also has some sort of a checklist that they follow, and it's double checked and traced back.
That's true. Yes. As far as scheduled maintenance, well, what the maintenance techs would have is more of maintenance manuals, and in certain areas they'd have checklists. Yeah, it's a system that where you have well-defined checklists and maintenance documentation that support what the technicians on the ground would do. That is to ensure that the pilot's safe to go. Even like some people say, oh, what if something's defective? Yes. Let's put it this way. This is human-built machinery. Even if something is defective, it's got probably another 10 or 20 more backups to support it. So if it's defective, yeah, it is defective, but it is acceptable for the next safe flight.
Got it. Do you think it makes sense, or is it possible even to have machines automate the maintenance requirements, sort of to take away from that, possibility of human error?
When you talk about machines doing the maintenance, yes, there is a possibility. But even when you talk about the possibility of them taking over that, even the machines doing the maintenance at some point would require maintenance. So there's a possibility of error there too. But the takeaway from all of this is you need a human being doing maintenance. The reason I say that is not to keep jobs or it's just nice. Sometimes when you look at a structure, you can look at it from different angles. You can look at it at specific angles. As a machine, would that be able to accommodate all the different variations on a specific structure? But with experience, a human being is able to readapt in a matter of seconds and say, okay, fine, this looks good. Let's look at it from a different angle. Maybe that structure is a little bit warped, or making immediate decisions. Let's say machinery would need to be pre-programmed to say that, okay, these are decisions that you need to make. But for a human being, you can actually change and adapt to those decisions that you need. I mean, it could be if you look at aviation, the amount of decision making you have just to release a single aircraft is enormous. You walk for a normal walk around. You would walk around, you would see the initial preliminary check. You're looking at your static wicks, looking at the basic structure, looking at your engine intakes, your exhaust. From there, if you did have anything reportable, from there you'd actually step in and say, okay, fine. This is what I've seen. I've seen there's a fan blade a little warped. Do I need to look in further? So then you look in further and you find, okay, fine. On the previous flight, it's had a bird ingestion. How much further do you look in? You wouldn't be able to get machinery to do that for you.
Nice. That's a good point, because you're right. Machines will do what they're programmed to, and that's it. Whereas humans, they can pivot, and they have that creative edge that something needs to be looked at in an immediate fashion to the moment. They can again pivot off that and rectify it. Do you see because like with Elon Musk, he's getting cars to go electric. Do you see the same thing with airplanes? I know there are some electric airplanes out there, but in terms of it being sort of commercially available and viable, do you see that in the future?
Well, let's put it this way: the aircraft are fully capable of doing it. With your Cap 3C land, it can do a full takeoff, land right up to the stand. So yes, it can do that, and aircraft are fully capable of doing that right now. It's just that with aircraft, you tend to be a little bit more cautious, because that assurance of human control still needs to be there. If left to it, yes, it's fully doable.
So we don't need the combustion engine for the aircraft. Like, it's fully able to go by batteries.
Oh, sorry, you're talking about, okay. Now, when you talk about a combustion engine for the aircraft right now, yes, that's the end thing. That's what's happening. When you talk about batteries, yes, Airbus are working on electric aircraft. They
Wow.
are they are talking about aircraft. There are a couple of electric aircraft already in service, and I mean, especially when I talk about that, I mean they're not in commercial service, but they are in as private users and stuff like that. But they are in service, and compared to what the electric motors used to do and what they can do right now, it's phenomenal. You, there's one of the BE-146s. They've taken off one of the engines and fitted an electric fan in there, and that's on test right now, and that's going on for quite a while. But like I said, before we actually get into that, the aviation authorities absolutely need to be confident that this aircraft flying completely electrically is going to take them from A to B and more. The and more is your insurance.
Got it. Yeah, because you always say, I want a car that takes me from A to B, but you have to come back to A, right? So that's
Yeah.
important. You have that longevity.
So and as a standard rule in aviation, what you do is yes, we're going to test it for what it's designed to do. But in aviation, yes, we'll test it for what it's designed to do, and we'll test 1.33 times the amount it's supposed to be doing. So it's always tested more than it's always tested more than what it's actually supposed to be doing. So
that's great. I'm glad to hear they're strict with it.
I'm sure everyone would be. Yeah.
Do you know if it's possible, or with the technology, can aircrafts get into space? Like, why are we using rockets, and why can't we use the aircrafts that we have?
Okay, aircraft were run on basically air combustion, atmospheric combustion. To do that, you'd have to carry your own oxygen into space. So when you talk about a rocket, it's carrying its own fuel and its oxidizer. So that's the reason it's not dependent on atmospheric air. Now, if you're talking about why would it be better if they moved out into space, the higher you go, the less air you have, the less air resistance you have. But you still need the air to have that engine running. So, like I said, you'll try to keep the aircraft optimally high so that it's got less friction, and not high enough so it runs the engine shut down. You need the oxygen to keep the engines running.
Got it. So at its base level, it still needs air to propel itself forward.
It does, yeah. Or it needs to carry its own supply of
oxygen. And I guess that's what they're trying to do. Like, again, with Peter Diamandis, Elon Musk trying to, and even Jeff Bezos now, he's quit Amazon to get the space race. They're trying to make rockets as seem as easy and as comfortable as the airlines that we travel on, right, to get into space.
Looking at the rate they're going, I think it won't be very long though. But it seems like it's the next in thing there. It's if you think about it, the current aircraft fly about 36 to 42,000 feet. The Concorde used to fly at 60,000, and to the point where it used to, it used to run on as efficient as possible. And the higher it went, the least drag. It used to try and get up that high so that it didn't have the drag to fight against anymore. And imagine a UK to a New York flight in about 2 hours. That was something at the time. And on some of the prototype aircraft, you actually, because it went up that high and you didn't have much of an atmosphere to protect you, on the prototype aircraft, we actually had cosmic ray detectors just to see that how much of radiation the passengers were exposed to. So there's a plus and minus to a little of everything when you're designing aircraft.
Got it. You don't want to compromise getting fried by radiation at the cost of speed.
You might save on the microwave, though. Not all the way.
If I can ask you one last question here. If you were given full freedom full resources in terms of, technology, software, hardware, finance, to design your own aircraft. What's one key feature you would like to include in your own personal design for an aircraft?
I think I can't really answer that because it's everything you take out or put into an aircraft has I can't say it has a plus or a minus. I know airlines that have refurbished the interiors, as in they've concentrated on passenger comfort. Oh, they're freaking amazing. They're really amazing. But then, now taking it a step back, to maintain that feature that they've put into the cabin costs you a bomb. To buy it costs you a bomb. If it was, I can't really say. Even if it was an aircraft itself, how it performed, that would take actually a whole lot of design research. Let's say you want to redesign engines, you want to reevaluate fuel consumption. I know a couple of friends in the airline also. They took a 787 out into flight just to see what is the passenger noise that they encountered. There was another airline that I got in touch with, and their goal was to see how they could use biofuels. Like I said, every step forward has something negative about it, but it depends on how much forward it actually takes you. Biofuels are great. I mean, but the thing is, they're not as available as regular fossil fuels. When you talk about research and development, there's a whole lot of money that goes into that. So when you talk about redesigning, I can't really say, I'm sorry, but it's definitely open. It just brings out a whole new thoughts to my head right now.
No, that's good. And once again, I didn't mean to put you on the spot, but it's akin to us being back in school and me coming at you for an inventive idea.
Yeah. Oh, there's a whole lot of ideas to it. It's a good question. It's a good question, and I wish there was just one answer to it. There is no one answer. It is it's multiple things. Like even if you see the current day aircraft, their technology marvels. And it's not just one. It's like even though they're technology marvels, you'll find these little glitches in them. But you take out the glitches, and then you realize that you lost a whole amazing system. You put the system back, and you got a glitch again. So it's a plus or minus of a little of everything. And now, which of the plus are you happy with, and which of the negatives can you live with? It's a little bit of everything. But no, you haven't put me on the spot. Like I said. It's actually a great question. Makes you really think. I know this is what I'm going to do tonight.
I guess no, you're right. I mean, it's like net worth. It's the net gain of the pros and the cons, right? What you end up with. Hopefully, that propels, no pun intended, in a forward direction. Yeah. But listen, Anil, thanks so much for coming on the podcast. And I really wanted to get you on because I know you're the go-to person for information on aircrafts and the industry. Because you're not only fascinated by it, but it's your passion and you're living and breathing it. So once again, I wish you well and the very best, and thank you again.
I feel you. Yep.